Hey, we spoke too soon. How's it going? This morning just kicked off our brand new daily vlog series. The goal is to get 10-minute length videos, not 3-hour videos. And yeah, I'm pleasantly surprised because I just rewatched that video and I was like, what did I talk about yesterday? And I was like, well, last week flopped. Last week I was studying number theory. I was working on building the just natural arithmetic system from the piano axioms using lean, using like the new proof assisted mathematics systems. And I was like, well, that flopped, but that's okay because I'm doing this stuff for myself. And hey, just last night, one of those videos really started popping off. So I successfully now have 2,000 view videos, and I'm very proud of that. For a brand new channel that started last month, I think that's pretty cool. We're at 2 already. From my experience with my other classical music channel, it's not that easy to hit 1,000. So, hey, that's cool. So that video was the older format, but I think that there's still something in the basic idea of like shorter videos, because that one was 28 minutes and it was just focused on one problem. I was just solving one lean problem. I was proving that a plus b quantity squared equals a squared plus b squared plus 2ab. Super simple fact. Everybody learns that, but you're just told that that's true in elementary school, or you learn it through the distributive property. But if you want to get very formal, you need to prove that everything is just a successor of 0. 0 is the only number, and then you have something else called a successor of a number. So this is like formalization of math into axioms. What can we prove is true, as opposed to believing it because it seems to work. That is, to me, what real math is. It is formal arguments of formal logic. Let's all just agree to assume the same thing here. We have the same starting point so that we're not just endlessly arguing definitions and semantics. Let's all agree on this starting point, and then from a common grounds of agreeance, of assumptions, what can we build out of that? It is honestly just like philosophy. It is philosophy. It is so... like pure math as a field of logic is, to me, a form of philosophy. And you might, if you're more interested in that idea, you might be interested in a video interview that I did a couple of weeks ago with Leo Lectures. And we really talked about, is math an art or is math a science? And the real answer is both. It is useful to solve physics problems, absolutely, and that is the motivation. It is incredibly useful to count how many acorns you have and to put them in a nice grid of, of acorns. And like, oh my gosh, why can't I find a rectangle that fits the number 7? I have 7 acorns. Why can't I find one? Maybe there are some numbers where the only rectangle is like a long rectangle. So there is math in the real world. There is math in nature. But then there's this other kind of math that we say, okay, let's keep stripping back until kind of like Descartes, like I think, therefore I am. Like, I can't doubt that this thing is true. I have a hard time believing why 2 parallel lines cannot cross. Let's just assume that that's true. And then you build math after that. And then to me, it's like the game is, let's invent math based on a set of commonly created, commonly agreed on axioms. Anyways, so I'm ranting again. This week we are kicking off a 10-minute series. So this is the beginning of today's live stream. I'm just going to hang out, practice math. I'm just going to study math with y'all. What did we do yesterday? Yesterday, I started trying to fill in my major gap in probability. So a Columbia math PhD friend, Jay, thanks Jay, friend of the channel, and another friend of the channel, Ben, they both pointed out that probability is a huge gap for me, especially if I'm considering trying to learn math for machine learning. I'm like, I love linear algebra. I graded linear algebra homework sets a long time ago in college. Therefore I can do machine learning. And they're like, you realize that probability is just as important, right? I'm like, but that's boring and I've never studied it. And they're like, well, you got to study it if you want to maybe go in that direction. I don't know what I'm doing. I got affected by the tech layoffs, and now it's like, I think I might want to go to grad school. But do I go to grad school in math or do I go to grad school in computer science? So I've worked as a software engineer for the last 10 years. And to me, I'm really interested in the cross-section, that intersection between the two. I'm interested in applying artificial intelligence to modern mathematics, to the modern formalization efforts. Speaking of formalization, with lean. And it ties really well with my love of test-driven development and automation in software. In software, you write a secondary program that proves that your first program is correct. I'm not ready yet. I'm not ready yet to reach out and email Kevin Buzzard, but we're getting back in shape. I'm re-sharpening my math skills, and I genuinely really want to study algebraic number theory. I want to understand the proof of Fermat's last theorem, ideally as a hobbyist. I think that would be such a badass goal of this channel. If I could help formalize Fermat's last theorem and understand it, truly understand it as a hobbyist, that sounds pretty cool, I think. All right, so this one might end up being a 15-minute, but that's okay, right? 15 minutes is fine, right? What we did yesterday, I think, is controversial. People kind of wince when I tell them that this is how I like to study math. I like to study math with index cards, okay? So what do you think? Because I think that there's an argument here. You can shuffle them, you can number them, and you can sort them again. If you're I used to take lecture notes in LaTeX in class, and I was so proud of how I had all my key bindings set up, and I was using Vim, and I had an HTC Evo with a kickstand and a Bluetooth keyboard, and I would take lecture notes. But nowadays, I just believe really strongly in the value of handwriting. I really believe in the muscle memory, in the benefits of muscle memory of writing something down. So that's to say, nowadays I prefer paper. If I'm going to write things on paper, my preferred old, long-lasting style is Moleskine, tiny Moleskine notebooks. These pocket notebooks, you can literally stick it in a pocket. They're not cheap, but if it inspires you to do math a little bit more because it's nice, because it feels nice, then it pays itself off. very quickly is my argument. Can't argue that for everything, but still. But yeah, like, I developed this style in the pandemic when I audited a graduate algebra class based on Serge Lang's algebra book. And that class was above my head. I was not ready even to just audit that class. Like, I could kind of follow along. Like, I was at the level of dumb and foot, but I was rusty. I was quite rusty at math. So I could follow along, and I was like, I can't solve these problems, but I can write them down. Like, I don't care who you are. I don't care what your math level is. If you dream of studying for Mall's last theorem, you can write down the proof. You can copy it by hand if you want, and you're not going to understand it all. You're not going to understand any of it. But I think that you can learn that way. And I think that that's very controversial. I think that's super controversial, but I believe in muscle memory, especially after the last 10 years really learning classical guitar and classical music deeply. Sometimes you just gotta woodshed. Sometimes you just gotta practice a scale and do it 20 times in a row. Sometimes you need to like set a counter and be like, I want it flawless 20 times in a row. I'm not leaving this chair until it's done. Sometimes you just do muscle memory. Sometimes you work very, very slowly, and you trust that over time your theory and your knowledge is going to catch up to your muscle memory, and that the two kind of meet in the middle. This also came from me watching my wife studying for medical exams, and just seeing how absolutely amazing these shared Anki decks that medical students have created to share with one another. Like, she had this humongous tattered book, the USMLE study guide, first aid for the USMLE, but then she would also use Anki just like all the time, like a machine, and just get through like hundreds of cards a day or something. And I would be like, dang, these are cool formats of cards. I've never seen these methods of flashcards. Like, I mean, this is kind of straightforward, but like when I was reading probability yesterday, back to probability, I would just reframe things in my own words. And even something like this, PRML, so I'm starting probability, or pattern recognition and machine learning by Bishop, recommended by Jay, thank you very much. Because blank in figure 110 is the blank of the blank, in each blank of that blank we have CI equals box, and therefore that equals that, which is the... I remember that this last one is the sum rule. I could sort of write down these summation formulas, but one of them is the addition of something else. Because of the number of instances in column I is the number of instances in each cell of that column, we have this, which is the sum rule. I think that this kind of method can really work. Like, I think it can really, really work. And one proof of that, I think, is that to get into Google, which is notorious for being the hardest data structures and algorithms interview, it's notorious for that. I mean, I've studied algorithms in the past, and I was like, I don't want to cram LeetCode anymore. What I did, I crammed for a weekend, the weekend before my real Google interview. I got a LeetCode Pro subscription. It's the one and only time I've ever used LeetCode. Got a LeetCode Pro subscription. I took a screenshot of the question statement and a screenshot of the answer, and I did that for the top 50 or top 100 questions, like equal on easy, medium, and hard. And then for a weekend, I just drilled with Anki. And when I was at the grocery store walking around, I would just literally be memorizing. And I'd be like, oh yeah, okay, there's the general strategy. Like, I know the general strategy of how to solve that problem. I don't have to write the actual code of the thing. But I know that if I see this type of problem, I apply this type of strategy. And whenever I wanted to, I could fork a card. You just duplicate a card, create another one that's just like a remix of the same idea. So like, I took some on PRML, and hey, Keanu, dude, I'll respond more in a moment, but that's super cool to hear that you have this book. You have PRML. It's great so far. I really like it. So this is the same card, but it's just in a different format. Sum rule. What is the sum rule? It's this, and you just like remix and keep creating variations of the same cards again and again. I think that it works really well. Like, I saw that from my wife's studying of medical school. So what did we do yesterday? We wrote down a couple of facts about probability from the theory, and I understood that. And then I took a breadth first approach on Norris. So I'm mixing different books, and I wrote down the first exercise. If you want to work these problems, these are great problems. Apparently they're mixed up. But I just wrote down the problem statements of the first exercise from every section. I guess I was doing it backwards. Definition and basic properties, blah, blah, blah. First exercise of section 2, definition and basic properties. First exercise of section 2, class structure. Like, literally just writing down the titles and getting that into my muscle memory and seeing that this same example pops up again and again, and he keeps saying, prove statements A, B, C. Like, I know that something called the ergodic theorem can be used, and then that transience matrix is used in 3 different sections, invariant distributions. Like, I don't really understand it. Obviously, I haven't solved these problems yet, but I have some level of like a roadmap idea of what this book is going to be about, and like the types of theorems and the types of questions that are asked. So I think that's what we're going to be doing today again. But I want to write down more probability problems, which are actually at my level at the moment. So cheers. Thank you for watching. It looks like we're at about 15 minutes. And I'll see you tomorrow. Cool. So now I'm just going to hang out, and we're just going to study math. And tomorrow morning, I'm going to clip this part and upload it as my daily vlog. So cheers. Cheers, y'all. Whew. All right. How's it going, Keanu, dude? Nice to meet you. How are you? So you have Norris as well as Bishop. These books look fantastic. It's forms of math that I haven't studied in the past. Like, I was a linear algebra TA. Heck yeah, dude. You're taking graduate level stochastic modeling, and we're using Norris or both. That's dope. Like, that's really cool. I want to have more people in the chat who actually understand this stuff. I am not at the graduate level at all. Another friend, Ben, another regular, I should say, besides Jay, Ben is a regular. He may pop in today at some point. He recommended Norris because I was like, I'm interested in Markov chains. He recommended this one. I'm not ready yet for this book, and that's okay. That is okay. We'll get there. But it just seems like such a beautiful field, Markov chains, to me. When I was a grader of linear algebra, the professor that I graded for used Markov chains as the example of matrix multiplication. Like, literally, like, when he introduced matrix multiplication, Markov chains was his application for that. Like, you don't even need to get into eigenvalues and eigenvectors to be like, oh, that's cool that when you raise this matrix to higher and higher degrees, it converges. Like, if you keep multiplying this matrix, it's getting closer and closer by itself. It gets closer and closer to some stable numbers. Sheldon Ross, stochastic processes and others. Heck yeah. Is Sheldon Ross the same Ross who wrote an analysis, like an undergraduate analysis book? I think so. I took an undergrad analysis from Ross. Ross analysis. Elementary analysis. Oh no, that's Kenneth Ross. Okay. Well, maybe they're siblings. Yeah, stochastic. I never learned anything about stochastic modeling or stochastic calculus or anything like that. It just sounds cool as heck. But yeah, my two math friends at the moment are both like stochastic experts, stochastic systems experts. He's got books for probability. Cool. Oh, that might be where I'm thinking of Ross, such as a first course in probability theory. That's what I need. I think what I need is a first course in probability theory. PRML has like an intro to probability section, and it looks like a super nice book. But I think I want a book that is like legit first course. All right. I'm like, all these books are burning a hole in my pocket. Like, I have been collecting so many books recently. And I think it's okay. It feels like I'm paying off my karma from being a teenager who downloaded a stupid amount of music from Napster. So, yeah, I can afford it. Let's do it. Ross, a first course in, and of course, I'm sure that I could find a PDF, but I just like books. I like books. I know, like, in terms of collecting. So, to me, like, yes, buying a bunch of $50 books adds up. No doubt about that. It really adds up. But the other problem is just that they take a lot of space. Like, my bookshelf is starting to get kind of packed up there. Like, the books all on the top, like the stacks of books on the top are pretty much all like my overflow of math books at the moment. I think I keep taking them out to show people my books, so I know that they could fit in the bookshelf way better, especially if I utilized space more intelligently instead of for display of books. But yeah, like, they take space, they take storage space, and if you move frequently, it's a pain. It is such a pain to move around frequently with like a huge collection of books, to me. But it's just not the worst thing to spend money on, I feel. Like, it's just not. There's way worse things to spend your money on. Even if it means that you have to pay more when moving or whatever. Okay, first course in probability, paperback. Sounds great. I love paperback books nowadays. There's a global edition. All right, well, I will figure this out later. But for now, I think I have enough probability stuff. Sometimes you have to own the book. Yeah. Looks beautiful. Thanks. I think you mean the messy stack of books. I appreciate it. It's beautiful in its way. Cool. I adore Dover books nowadays. Dover books to me are just brilliant. They're just such a godsend. They're like $15 each, and like almost as importantly to me, like with the Dover books, like this number theory, like you can carry it around like a novel. Like I was on the beach with where is it? Yeah, it's in the middle of that stack, but I've got Shilov. I have Shilov linear algebra up there. And I was literally on my honeymoon, chilling on the beach, you know, and solving determinant problems with a nice book that you can carry around, you know, and it's like about the size of your hand. It's way harder to chill on the beach with like a Springer hardcover book, right? There's something nice about this. So I'm growing to appreciate paperbacks a lot. Well, cool, man. So you asked, wait, you go to uni? No, I don't. I actually, I graduated university 15 years ago. So I've been a software engineer in Silicon Valley for the last 10-ish years. I got affected by layoffs, which is kind of a dream come true because the severance was phenomenal from Google. And I was honestly dying to go off and do my own thing, build my own apps, try to build some startups, as well as potentially go to grad school. I've flirted a lot with the idea of either going and getting a master's degree in mathematics, computer science, or classical guitar. It would be such a dream if I could do any of those and just get paid minimum wage, I feel. What? You look so young. Thank you. That's because I dress like a child. That's mostly why. And I need a haircut. I have a hair appointment for later this week. PRML is mostly a gentle introduction. Yeah, that's what it seems like, right? Like PRML, I need a gentle introduction at the moment because I'm rusty, you know, and that's okay. Like, I am rusty. For me, at least, you have access to Eisenbud commutative algebra. I have that. Yeah, it's over there. That is one of those where I was just very ambitious years and years ago, and I've just moved probably 2 or 3 times with that book around, and I've like barely cracked it open. Eisenbud is it just looks awesome. Like every time I flip through it, it does look super nice. But I'm not ready for that for a while. But someday I will be studying some algebraic geometry and commutative algebra. Go for grad school. I think that'd be fun, dude. It's just, if I'm going to do grad school, it's got to be like, obviously, he can go to grad school. Like, I need to be... Because I can self-study. I'm good at self-studying. I can learn on my own. I gotta get back into shape. I at least have to get to, you know, like a honors undergrad level math. Like, I want to be competitive for, like, a good program if I'm gonna do it. Oh, heck yeah, your second semester PhD CS. Nice. And you're studying stochastic stuff. My thought, honestly, is I'm really strongly considering the Georgia Tech remote masters. I know it's, like, fairly applied, but there are a lot of... from that Georgia Tech online master's degree, there are a lot of like super mathy courses like in stochastic processes, and I really liked computer science. I want to, if I got into it, like I would love to contribute to the lean formalization of Fermat's last theorem and application of artificial intelligence to like automated theorem proving. Yeah, like I think that'd be so cool. Dang, you're like doing algebraic geometry in a PhD CS. I'm so fascinated by what your research topic would be. Like, are you in like theoretical CS? Um, that sounds really cool. Like, you're using algebraic geometry in your CS PhD? Or are you just on paper a CS grad student, but you're actually solving math problems? Are you like applying algebraic geometry to theoretical CS or applied CS? That sounds super cool. Because, yeah, in my mind, algebraic geometry is one of those that's like, there's application within math. I guess you can call it applied math. I don't know. Okay, yeah. So you were kind of like an applied math person with the CS title. That's what I want. Like, I want to get a CS master's or PhD degree, but really just be like applied math in disguise. Like, I think that sounds so dope. And to me, the Georgia Tech program looks great because it's designed for people to be very part-time. You can take just like one course per semester, and it's pretty affordable, like from what I can tell. Like, I have a friend who did it, and oh, you're using it for automated theorem proving? Hell yeah, brother. Like, hit the subscribe button. I would love if you joined this chat. Did you see my my series from last week? Like, I looked at the natural number game for the first time in 5 years. Like, I've worked through the natural number game at the beginning of the pandemic when I was like thinking about math grad school, and I haven't touched it since. And I live relearned a tiny bit of lean. In particular, the last video is probably the only one really worth watching. I would love your thoughts on it. No, not really. You were really busy. Super understand. Yeah. Wouldn't expect, but like, I was wondering if that's why you found my channel, because I don't think you've been in the chat before, right? You subbed a few weeks back. Hell yeah. So I'm starting a brand new 10-minute daily format. You saw me filming today's filming, tomorrow's upload. Yeah, if you want to watch like the first 5 minutes of number theory number 13, proving a plus b squared, I would love your thoughts on that someday. Because I think it's a cool video. Like, I just work on that one problem, and I'm formalizing it with lean. I don't know, I'm trying to get people to see, like, oh, this looks like fun. This kind of looks like a video game. Like, what's that? Somebody asked, like, what is that game? I want to learn that. Yeah, right now, Lean 4 is the best software. That's my thought, too. Is that what you're using? Like, heck yeah, if we've got somebody working with Lean in the chat, because that's where I'm going to be going back and forth. Math for machine learning is like the clickbait name for it, but really like probability and linear algebra is 1 week, and then we alternate with number theory, both classical proofs as well as lean. So it's like alternating weeks are going to be probability, linear algebra, and then number theory and lean. Yeah, I really, really want to get involved with the whole community. So yeah, I've just started trying to learn lean as of a week ago. It looks amazing, and it looks and feels a lot like my love and subspecialty within software of test-driven development and unit testing and all of that sort of stuff. Yeah, cool. All right, well, it's super nice to meet you. I'm going to start zoning in for a little bit. If you want to chill, work on your own stuff, that's awesome. Otherwise, good to see you. And hope to see you again. I'm generally online roughly at about this time for me, the morning. I don't know where you're based, but I'm in the United States. So it's like 9:38 a.m. Whoa, fun fact, a lot of AI research institutes are putting Lean 4 as one of the requirements for machine reasoning. Yes, I have been contacted multiple times on LinkedIn about, hey, like, do you want to be paid $50 an hour, $35 to $50 an hour, and work from home? Like, I'm getting, like, contacted a bunch about contracting for, like, RLHF, like, fine-tuning AI models on, like, the validity of lean proofs. That sounds so cool to me. Like, that sounds super cool. So yeah, that's great. That's great to hear. I believe it. I think that lean is part of the key to getting AI to mathematically reason. And I don't know how I feel about that, because my feelings are very mixed about the safety of AI and whatnot. But I figure it's gonna happen. It's gonna happen. People are gonna do it, and I need the monies right now. So, and I need the skill and experience. Anyways, a lot of info there, but let's get started. Let's get cozy and practice some math. I'm going to continue with my heretical index card note-taking idea. And we're going to set Pomodoros 30 minutes at a time. Every 30 minutes I'll come back and chat for 5 minutes, take any questions, etc. Okay. Somebody told me to get rid of the broken cup. I've got a broken coffee mug I used in a video. Lol. Hey Siri, set a timer for 30 minutes. Cool. Let's do this. I wish I had a physical probability book, but that one is in the mail. Oh yeah, we can use the iPad for this. Okay. I still don't know where my Apple Pencil is. So, it looks like I'm going to keep using paper today. Alright, nice to meet you, Keanu dude. I hope that you are like a Keanu Reeves stan. But your real name might just be Keanu and you're sick of hearing that. But Keanu Reeves, what an American treasure. Alright, so we got PRML. It's really cool that Notability can dark mode everything, dark mode PDFs. I want to write down some exercises and try solving some exercises. For this Pomodoro, though, I am literally just going to muscle memory copy exercises. get some pen on paper ASMR going too. right, Pomodoro 1 is over. I hope that some of y'all got something done. I successfully wrote down several index cards. So we copied problems, what, 5, 6, 7, 8? Well, oh no, 4. I got 4, 5, 6, 7, and I'm midway through 8. So we got 4 exercises written down on index cards, and I have a little bit of muscle memory and a little bit of understanding, the smallest amount of understanding of what types of questions are going to be asked in this book, PRML. I think it's above me. I don't think I'm ready for this one yet. I need baby steps probability at the moment. But maybe not. Like, I could read the section, and I could read the theory section yesterday. So in this next Pomodoro, which I'll set a 5-minute timer to make sure our break, you should take a full 5-minute break when you're doing the Pomodoro method. Do not skip the breaks. Do not jump, be like, I'm ready to keep going. I want to keep going. Nope, force yourself to take the break. Because you need to breathe, you need to relax and chill, and be completely recharged and completely reset before you start the next iteration. So, and this is also a good chance to say hello. Hello, folks. Hit the like button. I see we got 3 people live, but only 1 like at the moment. So what the hell? I guess 2 people don't like this stream. That's okay. Hit the dislike button if you don't like the stream. But just like politics, the only wrong choice is to not vote. If you like the stream, hit the like button. If you dislike the stream, hit the dislike button. That would help me know what to focus on and what kind of stuff people like and dislike. How are you all feeling about this Pomodoro style type of stream? I like it. I think it's chill. Like, I'm hoping for chill. Just chill vibes. We're hanging out. I'm studying. I'm showing you some of the math that I'm working on, or at least trying to understand the tiniest little bit of. And I think it's cool to, have it up on the screen like this. So. Can you solve these problems? I can't. I definitely cannot. But someday I'll be able to. I believe that firmly. I believe it in my bones. We will be able to solve these problems someday. Even if it's a pretty long time horizon, we'll get there. We'll get there. Yeah. Hell yeah. Hell yeah, we got some comments, we got some activity on this new video I just posted this morning. Nice, man. I really like this new concept you came up with. Thanks, dude. Thanks, dude. I don't know if I just keep these study sessions up. I mean, probably not. I don't want them to just destroy my channel's algorithm karma. Let's going on here? 1093. Haha, that lean video is like really popping off. So it's at 1093 at the moment. And the only other video that is even in the same realm is Linear Algebra 1, which is at 1493. Linear Algebra 1 really leveled off at... It had like a big spike for a while. I'm way too obsessed about YouTube numbers. It had a pretty steep first derivative for a while until about 1013. So we're still on pace to match this other video. And it also took several days. It took like a while. From January 3rd we're at 0. January 19th we're at 1,000. So January 3rd to 19th. Dang. So more than 2 weeks. And then this new lean number theory video is now at 1,000 almost entirely yesterday. Yesterday it jumped. Where are we? How's it? The algorithm, y'all. The algorithm. Which book? Hey, this is... Nice to meet you. I have to move a window. Navjot, how are you? Nice to meet you. We are looking at Christopher Bishop, Pattern Recognition and Machine Learning. What about you? What are you studying? The book is a little chopped off. There we go. What are you studying? Are you a math person? I take it you are, because all the scary math symbols didn't scare you off, right? Cool. So we're doing Pomodoro Study With Me streams at the moment. My concept for this channel is I'm just studying, live learning and studying with y'all. But at the beginning of each video, I film a 10-minute daily vlog, daily update. So if you want to see that, I just uploaded a 10-minute video this morning. You might like it. I think it's cool. I would love to get more thoughts and eyes on that 10-minute format. But anyways, opinions are very welcome. Feedback is a gift. Oh wait, no, this is a 5-minute timer. We have to use Siri. Hey Siri, set a timer for 30 minutes.
30 minutes starting now.
This is gonna have to be the last one for me because I have to cram for a guitar master class that I have later today. So cool. Yeah, let's read the theory. Let's read the section a little bit more. This time I want to start from the beginning because I feel I jumped in too fast yesterday. It jumped straight to the section 2 on probability. Ooh, cool. You're studying linear algebra and optimization. Heck yeah. That's the stuff that I want to learn. I really want to learn exactly that. So hit the subscribe button. I'd love to ask you a million questions. Cool. Are you a grad student or a researcher? That would be so cool if we had some professors in the chat. Um, All right, Pomodoro is over. Come back to the full screen. How's it going, everybody? So we just remixed that page in a couple of ways. We're writing down some of the theory on pattern recognition and machine learning. At some point, I'm going to write down the definitions of each of these things. I just read about training sets, target vectors, training phases. I already know a lot of this, but it is great to get the precise terms that this book is going to be using. It's really cool to me that it uses the handwriting example on page 1 of this book. So consider I'm really summarizing some parts. I'm reading it. I'm reading the book fairly actively, thinking, okay, if this were a card that I'm going to be drilling and memorizing and practicing and seeing again and again, which sentences do I need to be on this card and which ones can I omit? How can I reframe some of this exposition into a way that's going to work better long term in a card? Can I reformat some of this information into bullet points? Can I, where do I put the blanks? What are the right parts of this sentence to use as a close deletion, fill in the blank type of index card? So that's what's going on. I think I gotta go, y'all. Thank you for watching. I'm gonna practice classical guitar because I have a master class with my teacher later today. And I'm very excited for that. So I'll play y'all a song for those who are here. Thank you for watching. I am going to switch over to my guitar channel. So if anybody wants to follow me there, you can follow me at jcpractices, youtube.com/@jcpractices. I'll be switching over to that channel momentarily. But first, let's go ahead and play a song. I haven't touched the guitar yet today, so here is a cold take. Truly cold take on Heitor Villa-Lobos. Prelude 1. This is one of the greatest guitar pieces, in my opinion, of all time. It's really nice to be on sabbatical, and I'm so grateful for this real privilege. I'm just lucky. It's like a lottery ticket that I'm able to spend some time in my life deeply pursuing two things that I think are the most beautiful things in the world: classical music, classical guitar specifically, and pure mathematics. So I hope you're enjoying this, and thank you for being part of the journey for that. Okay, so a major question today is, do I want to try to perform with the hoodie on? Let's see. Yeah, there it is. Thank you all for watching. I'm going to switch over to my guitar channel. I hope you have a beautiful day. Thank you for watching. Bye.